Well, this video is for Math 70, and this is for the first assignment on graphing. And when we're talking about graphing, we're talking about graphing on the x and y, what's sometimes called coordinate axes, and sometimes it's called the Cartesian plane, after René Descartes, who was a French mathematician, who was really one of the first Europeans to devise the idea of representing two-dimensional figures on a set of axes with position coordinates, very much the same way we do with latitude and longitude. Of course, those are spherical coordinates because they're on a sphere, which is the Earth, okay? Whereas these are plane coordinates because they're on a flat surface. Okay, so let's take a look at the assignment here. The first three problems, or the first six problems, are don't involve graphing. It's all about just getting the ordered pairs, okay? The x and y values, these are sometimes called ordered pairs. Okay, so problems 1 through 6 are all about just finding sets of ordered pairs given a particular formula here. In problem 2, it's y equals 2x minus 5, and I've got x values, -3, -2, -1, 0, and 1. And so all we want to do is plug in the x value for x, and then calculate. So that's -6 minus 5 is -11. Let's see here. -2, so that's -4 minus 5 is -9. Okay, plug in the -1, and we get -7. And 0 gives us -5. And then the 1 gives us, 2 minus 5, -3. Okay, so there are the y values for each of these x values. If we were to write them as ordered pairs, right, then we would put them in the parentheses and write them in that form. I didn't really ask you to do that on the instructions, so you don't really have to. But like I said, this is all about just finding the y values given the x value and the equation. Okay, problem 4. Let's see here. We've got x, and then y equals a half x plus 6. And the x's we're working with here are -2, 0, 2, 4, and 6. Okay, so again, just plug in the x values for x. Let's see, that should be -1 plus 6. Is 5. Plug in the 0, that'll be 6. Let's see, plug in the 2, and that'll be 7. Plug in the 4, and that'll be 8. And if we plug in the 6, then that'll be 9. Now notice when I had this fraction here, and I did this on all the problems in 1 through 6, if you've got a fraction there, it can be really helpful to choose x values that are a multiple of your denominator. Okay? So if your denominator is 3, then you might want to choose like -6, -3, 0, 3, 6, or something like that. Okay? That's how to get whole numbers for your y values if your coefficient for the x there is a fraction. Okay? All right. Let's look at problem 6. Okay. Problem 6. Got x and then y equals -2x plus 2. And the x's we've got are -2, -1, 0, 1, and 2. Okay, so again, plug in the x value, so that'll be 4 plus 2 is 6. And then let's see, 2 plus 2 is 4. 0 times negative 2 is 0, plus 2 is 2. Negative 2 plus 2 is 0. And then negative 4 plus 2 is negative 2. So there's our y values, and again, you can state these as ordered pairs if you want to, and that's how I did the answer key, was to write them as ordered pairs, or you can just leave them like this. Okay, so that's problems 1 through 6. That's a little bit of review from Math 60. And so now we want to take the extra step, and we want to make that table of values and then make a graph, okay? So you've got, if you have graph paper of your own, great, please use it. I will ask you to do some hand graphing on the midterm and on the final exam. When it comes to the quizzes, we're doing those online, so you'll have to do that using the technology. So, like I said, if you've got your own graph paper, great. If not, I'm going to post a PDF of something that a grid that you can use for graph paper, and you can print that out and go ahead and use it. Okay, so let's take a look at these. Problem 8, x plus y equals 9. All right, so first it says isolate the y variables and find 3 ordered pairs that satisfy the equation, and then graph the equation. All right, so first we want to get the y by itself. So let's move the x to the other side. And so there's our formula. Y equals negative x plus 9. We just need 3 points. Let's say negative 2, 0, and 3. Okay. So if x is negative 2, then y will be 11. If x is 0, then y will be 9, and if x is 3, then y will be 6. Okay, so all right, negative 2, 11. Let's see here, 0, 9, and 3, 6. And these should all fall in a straight line, especially if you're using graph paper. If you're using graph paper and these don't make a straight line, you've made a mistake, all right? This is a linear equation, and it's called a linear equation because it makes a straight line. So if it doesn't, you've got a mistake somewhere, and you should figure out where it is. Okay, let's see here. That's problem 8. Let's make some space here, and we'll keep going. All right, problem 10. Y minus 5x equals 2. Again, this is pretty straightforward. Let's see. We're going to add 5x to both sides. So y equals 5x plus 2. Let's see here. So let's make our 3 points, negative 2, 0, and 1. Negative 2, that's going to give us negative 10 plus 2 is negative 8. That's going to be 0 plus 2 is 2. And then positive 1, that's going to give us 5 plus 2 is 7. Okay. So let's make a graph here. All right, let's see. Negative 2 matches up with negative 8 there. 0, positive 2, and 1, 7. Now that's a pretty good straight line. I mean, that's why I say, you know, with graph paper and a ruler, you can really make a straight line. On the board, you know, I have to do my best here to make sure that these, you know, points are equidistant, right? Each of these tick marks is the same, and to plot my points carefully so that this comes out as close to being a straight line as possible. All right, problem 12. Let's see here. X plus 4y equals 12. Okay. So again, we want to get the y by itself. So let's move the x to the other side. 4y is negative x plus 12. And then we've got to divide everything by 4. Negative 1/4 x plus 3. Don't forget to divide everything over here by 4. Okay? When you divide everything in an equation by 4, you've got to divide everything. Okay? All right. So now we've got a fraction in front of the x, and so I'm going to pick x values that are multiples of 4, and we'll see how it goes. Okay, negative 1/4 times negative 4 plus 3, so that'll be positive 1 plus 3, which is 4. And then the 0 is pretty straightforward. That just gives us 3. And then the 8, if we put it in there, let's see, that'll give us negative 2 plus 3, positive 1. Okay. All right, so let's see here. Negative 4, positive 4, 0, 3, and 8, 1. And yeah, that gives us a pretty good straight line there. Okay. Let's see here. Let's look at problem 16. What do we have? 4x minus 3y equals negative 12. Okay. Well, notice that the y is negative. Okay. We can move the y over here and then the 12 over here if we want to do it that way. Or, now again, this negative is attached to the 3y. This 4x here is a positive 4x. So if we want to move it to the other side, we're going to have to subtract 4x on both sides. So those cancel out. Don't lose the negative sign for the 3y. Okay. And then we have to divide everything through by negative 3. Like that. So y is 4/3 x plus 4. Okay. So let's pick things that are multiples of 3. And let's see here. 4/3 times negative 3. So that's going to be what? Negative 4 plus 4 is 0. Okay. And that's going to be 0 plus 4 is 4. And what's that going to give us? 2, 8 plus 4 is 12. All right. So now we need to make a graph for this one. So let's see what we can do here. All right, let's see here. Negative 3, 0, 0, positive 4, and then 6, 12. And that gives us a pretty good straight line. That looks something like that. All right, let's see here. Problem 18. What do we have? 7x plus 5y equals 20. All right, so again, let's move the x to the other side. 5y, negative 7x plus 20. And then divide everything through by 5. And if you want to call this, what would that be, negative 1.4x, that's fine. There's nothing wrong with it. I like to keep it like this because it helps me know what to choose as my x's. All right, I'm picking multiples of that 5, which is in the denominator here. Okay, so negative 7/5 times negative 5 plus 4. So that gives us 7 plus 4, which is 11. 7/5 times 0 plus 4 is 0 plus 4, which is 4. And then negative 7/5 times 10 plus 4, let's see, that's going to be, what is that? Negative 14 plus 4 is negative 10. All right, so let's see what we get here. Okay, negative 5 goes up to positive 11 there. 0, 4. And then 10, negative 10 is going to be right about there. Yeah, and that makes a pretty good straight line that looks something like that. Okay, let's look at a couple more. What else? Well, let's look at problem 22. 2 minus x equals y plus 7. Okay, so to get the y by itself, we're just going to subtract 7 on both sides. So that'll get the y by itself here. 2 minus 7 is negative 5, and that minus x stays the same. Okay, let's make a table of values here. We'll pick one negative x, 0, and one positive x is usually a good idea. Let's see here, negative 5 minus negative 2. So here's the thing, this minus sign right here comes along with the equation, right? This negative sign here comes from the value of x, and that's really important. All right, that's something that people often make mistakes on. Okay, so those double negatives are going to change this to a plus 2, and then we'll have negative 5 plus 2 is negative 3. Let's put the 0 in there, and so that's negative 5 minus 0 is negative 5. And then we'll put the 1 in there. Negative 5 minus 1 is negative 6. And let's see here. Negative 2, negative 3. Right about there. 0, negative 5. And then 1, negative 6. And that'll give us a line that looks something like that. Okay. Now, I'm not labeling these tick marks because I'm making these larger ones equivalent to 5. Okay. When you do your work and turn it in on the midterm and or final, make sure to label your scale. Okay, make sure to label your number scale. I'm using tick marks that are 1, and I'm putting these big tick marks at multiples of 5. That's just saving me a little bit of time while I'm doing this lecture. Okay, when you turn your work in, make sure that you've indicated the scale of your tick marks in some way. Okay. All right, let's see what we've got here. What else are we going to do? Let's just do problem 26. Problem 26, 3x minus 4y equals negative 16. Okay, so again, this negative sign is attached to the 4y. This 3x is a positive 3x. And so, if we want to move this to the other side, we're going to need to subtract 3x and subtract 3x. This will be negative 4y equals negative 3x minus 16. And then we come in and we divide everything through by -4. So this will be 3/4 x plus 4. And if you want to call this 0.75, that's fine too. But remember that if you want whole numbers for your y coordinates, pick x coordinates that are multiples of 4. Let's see here. So what are we going to do? Let's just do -4, 0, and 4. Okay, so -4 times 3/4 should be -3 plus 4 is 1. 3/4 times 0 plus 4 will give us 4. And then 3/4 times 4, that's going to be 3 plus 4 is 7. All right. So, -4, +1, 0, 0, 4, and then 4, 7. Right about there. And that gives us a nice straight line. Okay, so I think this is a good, reintroduction to the basic ideas of graphing. Like I said, we're building on the concepts that were started in Math 60. These are the x's, these are the y's, okay? And every point on here is labeled xy. The x's always come first because x comes before y in the alphabet, okay? The x's are the horizontal axis, the y's are the vertical axis. And h comes before v in the alphabet as well, okay? If you have any questions about this, please let me know. Don't let it linger. If you're confused about things, please get it cleared up because we do have a midterm next week.